Now we're adding on from yesterday's lesson. We are going to be solving two-step inequalities. Yesterday was just one step. Today's going to be two steps. So let's get some practice in. Our first one says x divided by 5 plus 7 is greater than or equal to 13. Just like equations, the first thing we need to do is undo the addition or the subtraction. And then we undo the multiplication and division. Okay, so here to undo the addition or subtraction, we're adding 7. So we're going to subtract 7 from both sides. These cancel out. We have x over 5 is greater than or equal to 13 minus 7 is 6. So now we have x divided by 5 is greater than or equal to 6. Now I need to undo the multiplication and division. Here I'm dividing by 5. The opposite would be to multiply by 5. So I'm going to multiply by 5 on both sides. These cancel out. Dividing by 5, then multiplying by 5, that cancels out. So I'm left with x is greater than or equal to 6 times 5 is 30. So that means that my solution has to be a number that's greater than or equal to 30. Could it be 30? Yes, because 30 is equal to 30. Could it be 31? Yes, 31 is greater than 30. Could it be 29? No, 29 is not greater than or equal to 30. Let's see if this works. Let's pick a number that's greater than 30. Let's say 35. If I were to plug in 35 here, 35 divided by 5 is 7. 7 plus 7 is 14. Is 14 greater than or equal to 13? Yes, it is. So we prove that that works. So any number that's greater than or equal to 30 could represent x. Let's move on to our second example. 5 minus x is less than or equal to 40. Sometimes I don't like to deal with the subtraction. So if I wanted to, I could change this to adding the opposite. So this could be a 5 plus a negative x if we wanted to. But something else we can just know that this 5 is a positive 5. So what's the opposite of positive 5? Negative 5. So you can also treat it like that. So positive 5, negative 5, those cancel out. And then 40 minus 5 is 35. So that leaves us with negative x is less than or equal to 35. That would have also been the same if we did plus or adding the opposite. So it looks like our answer is complete. That was easy. Negative x is less than or equal to 35. Wrong. We can't keep this negative here. This negative cannot be here because the only thing that can be there when we have our solution is just the variable, not the variable plus a sign. So this variable, negative x, we have to get rid of the negative. Well, let's pretend, actually we don't need to pretend. This x represents how many x's? Hopefully you're saying 1. This is just 1x. So if I wanted to, I could put a 1 here. That doesn't change the value at all. It's a negative 1x. So if I treated this as a negative 1 and I wanted to just get this x by itself, you can see that this negative 1 is a coefficient, which means that we're multiplying this negative 1 times x. So the inverse would be to divide by negative 1, divide by negative 1. So now these two cancel each other out. We multiplied by negative 1, divided by negative 1. So that leaves us with x. And then we divided by a negative. Remember our rule from yesterday. When you multiply or divide by a negative number, the sign flips. And we proved why that's true in yesterday's video. So go back and watch that if you need to. So this sign is going to flip. And then 35 divided by negative 1 is a negative 35. So that would be our response. X is going to represent anything that's greater than or equal to negative 35. And just to prove to you that that's true, let's pick a number that's greater than or equal to negative 35. What if we did negative 30? Negative 30 is greater than negative 35. So I'm gonna rewrite, we had 5 minus x. This was our original. If I replace x with a negative 30, that means this would be 5 minus a negative 30. It's less than or equal to 40. 5 minus a negative 30. Well, when we subtract, that's the same as adding the opposite. So really this is like 5 plus 30, which is 35. And 35 is still less than or equal to 40. So that's why this is true. One more for practice. Notice that this number, we have one number on the left side and then a couple numbers on the right side. It doesn't matter. That doesn't change the way we solve things. Okay, so remember we undo the addition and subtraction first. So here we're adding this 4, so I need to subtract 4 from both sides. That takes care of this 4. 20 minus 4 is 16. So this reads 16 is greater than j over 4. J over 4, or j divided by 4. The opposite of dividing by 4 would be to multiply by 4. Got to do it to both sides. These sides cancel out. 16 times 4, let's see, 15 times 4 is 60, so that'd be 64. 64 is greater than j, or j is less than 64. Let's think of a number that's less than 64. Let's do 20. 20 is less than 64. Let's say j here equals 20. What's 20 divided by 4? 5. 5 plus 4 is 9. Is 9 less than 20, or is 20 greater than 9? Yes, it is. So this becomes true. So j just has to be anything that's less than 64. It's kind of weird if we have the variable on this side. Another way you could write this, right? 64 is greater than j, so that means like j has to be less than 64. So you could write it either way. Just make sure you understand the meaning of your answer.